So in this class we will discuss delta modulation. You know that in a pulse code modulation system, each sample is encoded using an n-bit data. That means a PCM system requires a much wider bandwidth compared to any other modulation schemes. So a delta modulation is an alternative for this. That is, in delta modulation, a 1-bit data is transmitted. That is, each sample is represented by its 1-bit equivalent. Okay. So, in a practical delta modulated circuit, the present value of the input data is compared with the previous sample value, and the transmitted bit depends on whether the amplitude is less than or greater than the previous sample. That is, the input signal is first converted into a stair-step waveform or a stair-step approximated signal whose step size is constant. Okay, and in a comparator, the difference between the input signal x of t and the stair-step approximated signal is compared, and it is brought to two levels, plus delta and minus delta. So if the present sample value is greater than the previous sampled value, a 1 is transmitted, and if the present sample value is less than the previous sample value, a binary 0 is transmitted. So this can be easily understood from this waveform. So this is our original information or the message signal that is represented by using m of t, and this diagram represents the stair-step approximated waveform. Okay, so whenever the stair-step waveform is greater than the message signal, a 1 is transmitted, and whenever the stair-step waveform is less than the original message, a 0 is transmitted. We can see here, so for this time duration, stair-step waveform is greater than the original message, so a 1 is transmitted, and in this time duration, the stair-step waveform is less than the original message, so a 0 is transmitted. Okay, so upon comparison between the present data and its stair-step approximated value, a 1-bit equivalent of the sample is being transmitted. Okay, so this is a practical delta modulated circuit. It comprises a summer, a quantizer, a 1-bit quantizer, and an accumulator circuit. So in this accumulator circuit, the function of this accumulator circuit is to produce a stair-step approximation of the input waveform. Okay, so here in this comparator or the summer amplifier, the difference between the present sample and the previous sample is taken, and if the present sample value is greater, a 1 is transmitted, and if it is less than the previous value, a 0 is transmitted. Okay, so actually here in this accumulator circuit, the data is 1-bit quantized. Okay, and after producing a delay of Ts duration, the signal is fed back to the summer amplifier. And on addition of these two signals, we are obtaining a stair-step waveform of the input itself, but with a delay. Okay, so here in this circuit, we are comparing the present input value and a delayed version of the input. Okay, now in a practical delta demodulated circuit, the incoming zeros and ones are first converted into a stair-step waveform, and thereafter the stair-step waveform is smoothened or demodulated with the help of a low-pass filter. Alright, so what is done here? If a 1 is received, a plus delta variation is obtained, and if a 0 is received, a minus delta. If a 0 is received, a minus delta variation is obtained here. So at this point we are obtaining a stair-step approximation of the incoming zeros and ones. Okay, and thereafter it is smoothened with the help of this low-pass filter. Now, there are two advantages for this delta modulation when compared to PCM system. As the first advantage, the transmission bandwidth required is very less because it is transmitting 1 bit per sample. Okay, and it's very easy to design such a modulator and demodulator. Okay, but there exists some kind of noise in the case of delta modulation, that is slope overload error and granular noise. So slope overload error is nothing but, suppose the input signal x of t is increasing or decreasing at a faster rate, the stair-step, we can see here the stair-step step size is very high, so some portions of the input may not be sampled, and that kind of noise is known as slope overload error. And if the input signal is held a constant, in this time period the input signal is held a constant, but even then the modulator output will be switching in between plus delta and minus delta. Okay, so this kind of noise is known as granular noise. So to avoid slope overload and granular noise, we go for adaptive delta modulation.